So I have got the topic advancing solid-state lighting through innovative micro-optic solutions. Maybe I will repeat something what the speaker before already told you, but then I will be quite brief. And I want also to mention the project Fabulous, where we have been part and where we learned quite a bit the last 5 years. And yeah, give you here some insights. As maybe some people don't know, Zumtobel, just a brief introduction of our company. So we are the second largest lighting company in Europe. We have a revenue of 1.1 billion, over 5,000 employees and sales offices worldwide. We consist of 3 major brands, which is Zumtobel for indoor illumination, Phone for in- and outdoor illumination, and Tridonic for components like light sources, driver ballasts, and also control units. We offer innovative high-quality lighting solutions and components as well as associated services for our customers worldwide. So it's not that we only have products like we have some luminaires, we have some drivers, but we also really focus on lighting solutions. And now with all the smart lighting, we have of course also the services in place which you can do with smart lighting solutions. Here a few figures or pictures of some projects from the last year. So here you can see we are in libraries, for example, we are in office spaces, but we are also in public spaces like airports, and we are in showrooms like the Maserati and the Czech Republic, and we also illuminate stadiums. So maybe that. Now let's start. So I'm a little bit repeating. So what are really micro-optics, freeform micro-optics? What's the creation process and how do we use it in general lighting? So freeform optics are not constricted by any symmetry requirements, so you are very free in your design. They can be transmissive or reflective, what we heard before, so they can be on a reflector or on a lens, also on both sides of the lens. They can be arranged in grids, which can be regular or irregular, and then you get the freeform micro-optics arrays, and that's what we used in our project in Fabulous. What are the advantages of micro-optics? So in imaging, the number of the elements can be reduced as the image forming and the aberration correction can be combined in one element or in few elements. So, and then of course if you have less elements you can increase the efficiency of these kind of optics. In lighting we mainly deal with non-imaging optics, so there we have the possibility really to achieve also asymmetric lighting distribution, quite high asymmetric lighting distribution. What we also need for good illumination is color mixing and homogenization features in our optics. And in the end, of course, what we heard before, the micro lens arrays are very lightweight and consume little space, which are very beneficial for our product design. And of course, also mentioned by before, don't forget the aesthetical design of our products. Here I come now to the creation process. It starts with the modeling and simulation. Then we have the origination, the manufacturing of the actual master. Then the generation of the tool, which is mostly the first, second, or third replica of the master. There can also be the upscaling process included. Then we have the replication with Force and Fabulous UV imprint only. And then the integration of the part inside the luminaire. For all those steps, quality is an issue. So if the origination, something goes wrong, of course, you shouldn't find out then first when you integrate your part. So quality control is very crucial. For the design, there are several methods which can be used. One of them is, for example, rain mapping. Then for the modeling, you usually deal with surfaces, or then also a regular pattern of those. And then when it comes to look if these models comply with the requirements of the application, you have to use the simulation, which we mainly use with Monte Carlo ray tracing as we are in this regime, but with micro-optics it can, of course, as mentioned before, far more complex if you have also diffractive features in your optic band. For the origination inside fabless, we had several techniques available. So we had the diamond micromachining, the laser micromachining, femtosecond laser ablation, grayscale laser lithography, and two-photon absorption. And it wasn't always easy to choose the right technology. They are really, you have to find the best fit to your design. It depends on the size, but also on the topology of your design. Do you have a strong gradients or not? So what kind of rounding radius are acceptable? All these kind of thinking goes into it, and also, of course, the size of the master, which can be done with the different kind of technologies, which are in a certain cost limit. So it's good to have here, at least from my point of view and from the lighting company, to have consultants in this regard. In one of our projects inside Fairbiz, we had also an upscaling process. Here we got, for example, a master by power photonics with a size around 20 millimeters. And in the end, we wanted to have optical parts in the size of 30 by 30 centimeters. Neo searched here with step and repeat, an upscaling process. Upscaling was, I think, up to a few years, still a very crucial step because the stitching lines were always visible and disturbing the aesthetical appearance, at least this, of the design, sometimes even the function. But this becomes better and better, so I'm here very optimistic also for the future. The replication process, we have also heard before, all of them have in common that you disperse a lacquer onto a substrate, which can be film or rigid, like a plastic plate or a glass master. And then the replication is very precise in UV imprinting, so I think in general you could also get it with other technologies, but in UV imprinting, it's a technology which from its nature is very precise in the features. Now I come back to the quality. One point is the data transfer, so that really mainly the originator gets the same data what you used in your modeling and in your simulation. This is also now getting better and better, but let's say in the beginning of Fairbiz we still had problems here that data or accuracy got lost. Materials is a big topic. So also we did some material testing, but there are of course an overwhelming variety of materials, and we don't have the direct influence which materials are actually used, but really the requirements from lighting are maybe not so harsh like in automotive, but we have to guarantee very long lifetime. I'll come to that later on. So testing, accelerated testing, and then also for multi-material systems to do lifetime extrapolation is not so easy. Then we have, of course, the geometrical measurements we should have. It's not always them, but we should have in all the steps. That we don't have surprises later on in the creation process. And here we have the laser scanning microscope, SEM, white light interferometry, and profiling meter. Also here, it's crucial to use the correct method, otherwise you see features, not in the measurement, but which you see later on in the application. And also steep angles, I think, are for all of them very demanding, and sometimes also size measured. So with one technology we can measure quite a lot, big areas of your samples, with others only small. So here it's still also, you have to know which technology to choose and how to interpret the results. Now I come to our application. So we had a wall washing application. Wall washing is one of the more demanding applications in lighting, as you have to have a very precise illumination pattern and with a high homogeneity. Usually wall washing besides, of course, other leisure areas like in hotels or other shopping areas. Also sometimes we have it in museum, and there especially it's very crucial because the requirements for homogeneity are very high. So here it's freeform micro-optics arrays are a good method to use. Then you have to have a very asymmetric distribution, not only very precise, but it is very asymmetric, so you have to redirect quite a large amount of your light coming from the light source. And also good in this respect was a big flexibility, as the optical element is very thin, even if it's on a film or on a plate. You can rearrange it or combine it with your product. Some of the challenges I already mentioned, but I'd like to point out them again. So really the large sizes, you have seen the showroom of the Maserati before. These had really quite large light-emitting areas. So step and repeat, it's very important, and also what we heard before, that electroplacing becomes bigger and bigger. It's very in our favor here. Then we have the long lifetime requirements. I also touched this before, so these lifetime extrapolations are not so easy for us, but we are in this lifetime testing quite a bit, because usually the suppliers of materials testing their materials only to up to a level where they see that they have good quality in which that they last long, but sometimes the requirement in lighting is even higher than that, so we have to know what to expect. And here, of course, all humidity, thermal, and also irradiation, it's an issue, even if it's indoor lighting, so don't forget the intensity of the LEDs, which become much more, or has become much more over the last 10 years. And in the end, even if it's, let's say, only lighting, which is mainly non-imaging optics, we still need a high precision. So we had also some quite experience that even tiny surface roughness or scratches can destroy the distribution what we need. So we have also, so it's only lighting, quite high requirements on the whole value chain, creation value chain, but this has to be matched with our cost expectations. So this, I think, is still a challenge, but there are already good solutions on the market which we also use. And the benefits are just too big not to use micro-optics in our products, so we include them in our products. And then, for example, also what our story which we have in Zumtobel for the natural daylight in office lighting. Here you need a precise lighting distribution combined with spectra, and also these spectra are changing over the day. And if you have more than one light sources in your luminaire, then of course you need a good homogenization and also color mixing. So for us, the benefits of these micro-optics are just overwhelming, that we are more and more using them. Also, of course, seeing some difficulties there. Thank you very much. Are there any questions?